it's fair to say that mathematics can be considered a language, right? It has a lot of the characteristics of a language. And here are some processes that are involved in mathematics. So for example, you may see this image, okay, in reality. And as you look at this image, you are perceiving, and words such as one nest with 4 eggs, another with 4 eggs, also one another with 3 eggs will come into your mind, right? These are the words that will obviously automatically appear in your mind because you are perceiving this image with like 4 and eggs and 4 and eggs and 3 is equal to, and also 11 eggs, because we are automatically, apart from qualifying, we are quantifying also. You are looking at the eggs, looking at the color, they are brown, they are shiny, you know, the nest looking, you know, with brown twigs and so. But at the same time, you are counting, because we automatically qualify and quantify when we perceive our environment. And then we may need to communicate what we see, we may need to write what the words that are appearing in our minds, and we have to use symbols. And some of the ancient symbols of counting was strokes, right? 4 strokes or vertical strokes, and sometimes you have horizontal strokes, but here you have vertical strokes, 1, 2, 3, 4 of them, and 1, 2, 3, 4, and 1, 2, 3, and an ease, and then you're getting 11 strokes, eggs equal, okay? But then you have the other symbol, the Indian symbols of 4 and eggs, and the Latin version abbreviation of and et, because et in Latin is et, and 4 and 3 is equal to 11. And then you have the modern notation, 4e plus 4e plus 3e is equal to 11e, okay? And this actually shows you that the word and in arithmetic is the symbol plus. So plus and is likely the same thing, okay? So you can see a translation from words to symbols, okay? So that's why it is fair to say that mathematics has some characteristic of language, because you want to communicate in written form using symbols what you perceive, okay? So now, words, 1 nest with 4 and with 4 eggs also, and another with 3. Right, 4 and 3 is equal to 11, symbolic form, and modern mathematical form, 4 plus 4 plus 4 plus 3, sorry, is equal to 11e, e for eggs. And you can see the transition from words to symbols, okay? So it is fair to say that the language, mathematics, first starts when we objectively perceive the real world with the 5 senses, okay? Seeing is very predominant, but we can also hear and smell and taste and feel, okay? Then in order to communicate that subjective abstraction of the mental image that was formed in the visual cortex and other areas, we design diagrams and graphs. We also convert words to symbols. In that way, we facilitate the documentation, thus written communication of ideas involving numerical analysis, all right? Because when we perceive from a mental image, and we need to communicate that image, and we have to use words to symbols, because we have to write and document in order to communicate what we perceive, okay? So now we take a look at the plus sign, all right? The origin of the plus sign. The origin of the plus sign is credited to the 14th century French mathematician named Nicolas d'Orésem, all right? When he was writing his math book, he found himself having to write the word et over and over, okay? Tria et quattro aquilia sum septem, that's Latin. Okay, trois et quatre égale 7, that's French. And you have 3 and 4 is equal to 7, that's English. So you have those 3 translations of those 3 sentences in 3 different languages, but as you can see, the Latin and the French, they both use the word et or et for and. Okay, so he therefore then replaced the word it or et with the letter T, okay, which then evolved to the symbol plus. So you can see that that's where our plus sign originated from. The whole idea of changing a word, in that case it's a two-letter word, and to a symbol or one letter T, which the horizontal line was placed in the middle, because the T now, the horizontal line is a little up, higher up, but with the plus, the horizontal line is right in the middle, and then a word converted into a symbol to facilitate communication, okay, of quantitative analysis, okay. 3 and 4 is equal to 7. So here in this table, as you can see, the words to speak is et, and the symbols to write is equal to the plus sign. And always take note, in arithmetic, the word and is plus. So if you say 2 and a half, all right, you are basically saying 2 plus a half. Okay, you can, you know, please take note of that. Okay. The equal sign. The origin of the equal sign is credited to the 16th century mathematician named Robert Recor. Okay, when he was writing his math book again, writing because you want to communicate, so you have to write. Written communication, you must write symbols, letters, but in math it's symbols, because the letters sometimes is too much. For example, he found himself having to write the words is equal to over and over. So in Latin, you say tria et quattro, equalia son septem. All right, so equal is equal to is equalia son. All right, in Latin, trois et quatre égale sept, égale sept. Okay, so equal is equal to in French is égal. And you can see the similarities. And 3 and 4 is equal to 7. So instead of writing is equal to in the native language over and over, all right, he therefore replaced the word is equal to with 2 horizontal parallel lines of equal length. Okay, so the words to speak équalia son, all right, written symbolically is 2 equal lines. So you can see the whole transition of words to symbols, and that is prevalent in mathematics. Okay, so always bear that in mind. Again, our numerical system, the numbers, the numericals that we use, we know the Romans use horizontal slashes. Okay, I think the Mayans use the Romans use vertical slashes, and the Mayans using horizontal slashes. You can Google it. And the Egyptians have other hieroglyphs using for, you know, numerical, changing what you perceive to symbol in order to communicate, you know, to write, communicate in written form, you need to communicate. Okay, but in India now, and also and it went on to the Arabic nations, the origin of the equal sign is credited to the Indian mathematicians. As you can see, as Google says, Hindu Arabic numerals set of 10 symbols, a round circle, a horizontal line, a zigzag, we call it 3, and 2, 1, and 3, and this one is 4, 5, 6, 7, 8. That's what we call it in English. Okay, that represent the numbers in the decimal number system. From that, we can make any number from those 10 digits, those 10 symbols, any number, any value can be created. They originated in India in the 6th and 7th century and were introduced to Europe through the writings of the Middle Eastern mathematicians, especially Al-Khwarizmi and Al-Kindi, about 12th century. All right. So now even the symbol 0, even the concept of 0 itself, and even to have a symbol for it, originated in India and also I think the Mayans. So while in Europe, the 0 was not yet invented, okay, was not being used, it was being used in India and in the Mayan territory, that's in South America. These symbols were designed via the rule of counting the number of acute and right angles created. Okay, so the whole idea of counting again, and instead of writing strokes or, you know, one symbol to represent the value. Okay, so what they did now, very ingeniously, they actually designed a symbol with the number of angles, acute and right. So with that, the whole counting is represented in one symbol. So for example, the circle, we call it 0 in English. Here it is. It has no acute, neither right angle to count exactly. So nothing, because in mathematics, 0, is a symbol to represent nothing. Okay, no quantity is present. Then the number 1, as you can see, there's only one acute angle. So that's why the number 1 has that shape. Okay, and most times you just write a vertical line, but really and truly, that's how the number 1 originated. And look at the 2 looking like a Z, because there are 2 acute angles. And as you can see now, with time, our 2 start to take a curly form and so forth, but that's where it originated from, 2 acute angles. The 3, 1, 2, 3 acute angles. And that's how, look at our 3 evolve, with time. And the 4, look at the 4. Look at the shape, and you can count the angle, the acute and the right angle. There are 2 right angles, 1, 2, 3, 4. Okay, that's why our 4 has that shape, as you can look at the similarity. The 5, 1, 2, 3, 4, 5 right angle triangles. 5 right angles, sorry, 5 right angles. And look at the 5 now, our modern 5, has evolved to, and that's what languages evolved, you see. Everything, changes with time, but you can see this, the origin, and you can see the similarities where it originated from. The 6 has become very rounded, but originally that's how it started. 1, 2, 3, 4, 5, 6 right angles. Or 7 with 1 right angle and the rest acute. 1, 2, 3, 4, 5, 6, 7. So the true 7 is the one with the cross, with the the horizontal cross and a little line there. That is really, but look at how our 7 now becomes, it even want to look like a 1, 1 acute angle, but really and truly that is the true 7. I think there are some countries who still use that 7 with this cross. I think the French, I think. And the 8, look at the 8, or wrong it has, but that's how it has become, but that's how it was originated. And the 9 right angle triangle, and 9 right angles, 1, 2, 3, 4, 5, 6, 7, 8, 9 right angles, and look at how it has become rounded. Okay, so you can see the whole, the whole attempt to create symbols to represent what we perceive. All right, and in order to communicate. Okay, and so therefore now, instead of writing words, we write those symbols, but then we still have to, when we read it, we still have to say the words. 3 plus 4 is equal to 7, and we call it mathematics. But we can clearly remember where this originated from. Okay, THREE in English, TROIS in French, and so forth. 3 and 4 is 7. 3 plus 4 is equal to 7. Maths can be viewed as a language, okay, to communicate using symbols when we are doing numerical analysis. Yes.